So today we are going to start with a new topic that is shapes of molecules, right? Okay, yeah. So today we are going to start the new topic, shapes of molecules. So we explain the shapes of molecules, that how or which kind of shapes molecules will attain on the basis of VSEPR theory, which is called valence shell electron pair repulsion theory. So basically the shapes formed by the molecules are actually based on the number of uh, electrons around the central atom and how these electrons, repel each other. So we know electrons are all negatively charged. So the electron pairs in the molecule repel each other as they all are negatively charged, they have a same charge. In any molecule, there are two types of pairs of electrons. One are called bond pairs, which are also named as shared pair as well. And the other type of a pair of electrons are called lone pairs. Till here, is this clear, Alishwa?
Yes, sir.
Okay. Now, the lone pair of electrons are closer to the nucleus than the bond pair. It is simple. See, for example, if I give you the example of ammonia. Uh, okay, just give me a minute, please.
Yes, sir.
Yes. For example, if I give you the example of ammonia, in ammonia, we see that there are three bond pairs between nitrogen and hydrogen atoms, and there is a one lone pair, right? So
Yes, sir.
talk about this bond pair, as this bond pair is between two atoms, so it is attracted by both the atoms. Due to this, it is little away from the nucleus of the central atom as compared to the lone pairs, because there is no other atom on the other side of the lone pair which is attracting that lone pair. And that's why we say that lone pairs are closer to the nucleus than bond pair. Is this understandable?
Yes.
If you have any doubt in this, please ask.
Could you give another example of it?
Uh, Sorry, can you repeat?
Could you give another example of it?
Yeah, I'm giving this example to you. For example, if you see, this is a nitrogen, and here we have a shared pair between nitrogen and hydrogen, right?
Yes.
Here we have a shared pair between hydrogen and nitrogen, and here we have a shared pair between hydrogen and nitrogen, and here I have a lone pair, right?
Yes, sir.
Is there any atom opposite to this lone pair over here which can attract this lone pair?
No.
No. But on this bond pair, there is a hydrogen atom over here which is attracting this bond pair towards itself, right?
Yes.
So due to this, the bond pairs gets a little away from the central atom as compared to this lone pair.
Oh, okay.
Understand?
Yes, sir.
Okay. So now, if the lone pair are very closer to the nucleus, so when we compare the repulsion between these pairs, we can conclude if there are more than one lone pair, so the two lone pairs repel each other the most. because they are very closer, right? The repulsion between a lone pair and bond pair is moderate, and the repulsion between bond pairs are least. So it means, for example, if I take the example of oxygen from water, let me do this. Yeah. So see, the angle between these two lone pair would be a greatest because these are the lone pairs and they repel the most. The angle between the lone pair and bond pair would be going to be smaller than the previous one because their repulsion is moderate, and the angle between these two bond pairs is going to be the smallest because the repulsion between the bond pair is least. Is this understandable?
Yes, sir. But doesn't it depend on us how we draw the plot and cross diagrams if we put the bond pairs opposite to each other?
Yeah, that's what we do. We usually do in like this. We put the bond pairs and then we put the lone pairs like this. Is this clear?
Yes, sir.
Okay. So when their molecule is formed, these pair of electrons arrange in such a way that the repulsion among them is minimized. This arrangement defines the shape of the molecule. So the pair of electrons arrange themselves automatically in such a way that they have a maximum distance in between them due to the repulsion, and as the position they attain or how they oriented is the way by which they get minimum repulsion from each other. Is this clear?
Yes, sir.
Okay. So there must be a central atom in a molecule to reduce its shape. So whenever we have to reduce the shape, there must be a central atom. So if you look at this molecule, can you say any atom among these between these is a central one?
Yes.
No, there is no central one, right? Now have a look at these shapes. In this shape, this one is considered as a central atom, right?
Yes, sir.
In this shape, this one is considered as a central atom. And over here,
Yes.
these two are considered as a central atom. Okay. So to
Yes.
deduce the shape of any molecule on the basis of valence shell electron pair repulsion theory, there must be a central atom in it. For example, if I give you another example, let's have a look over here. So I ask you how many central atoms are here.
Five.
Very good. There are 5 central atoms. 1, 2, 3, 4, 5. Is this understandable? How to figure out
Yes, sir.
which one are central? So it's very easy. Any atom which is surrounded by at least 2 atoms is the one which is considered as a central atom, right?
Yes, sir.
Okay. There is another important thing. For example, these are 4 bond pairs, right?
Yes.
Okay. Now have a look over here. If you see the number of bonds, there are 4. So we can say there are 4 bond pairs here as well, right? Right?
Yes.
And over here, how many bond pairs are there?
4.
4. So in actual, all of these shapes have 4 bond pairs. But for the purpose of deducing the shape, if there are multiple bond pairs between the 2 atoms, we consider them as a 1 bond pair only. So to deduce or to decide a shape of this molecule, instead of 4, we consider them only 2 bond pairs. But in actual, there are 4 bond pairs, okay?
Yes, sir.
In the same way, if you look over here, there are 4 bond pairs actually, but for the purpose to decide the shape, we consider this as a one bond pair and we consider this as a one bond pair. Is this understandable?
Yes, sir.
If you have any query, any question till here, please ask.
Mm,
Okay, now have a look at this structure. If I ask you, how many actually bond pairs are there?
5.
5. So around this atom, if I encircle this one, how many actual bond pairs around this atom?
4.
4. And if you have to decide the shape, how many bond pairs around this atom?
2.
2. I hope it's clear, right?
Yes, sir.
Okay. Now, okay, so here we got a table and you have to understand all these shapes. Okay. So are you using a laptop or a tablet to take the class?
Sir, I'm using my phone, but I do have a laptop.
Okay. Actually, I am sharing one link with you and I want you to,
Open it.
yeah, open that link. Just,
Could you give me one moment so I can bring it?
yeah, sure.
Yes, sir.
Have you received the link on a chat?
Yes, sir.
Okay, open that link. Yes, did you open it?
Yes, sir.
Okay, and are you seeing my screen, right?
Yes, sir.
Okay, so see, here you can see the central atom. Now you are just observing the central atom, right?
Yes, sir.
That is a purple ball. Now I am going to put a one bond and the other bond. So now it has how many bond pairs?
2.
2 bond pairs. So as we say that the bonds orient in such a way to minimize their repulsion. So do you think any other orientation in which they can arrange themselves to get the minimum repulsion beside this one?
No. They're on
No.
the opposite side.
Yeah, they are exactly on the opposite side. So they got the angle of 180. If I try to move any other bond, the bond angle decreases from 180, right? See, if I'm trying to bend them, let's have a look. If I move this way, the angle decreases. It got 180 over here, for example. Yeah. And if I try to move upward, see, again, they come closer and the bond angle decreases. So if there is so how many bond pairs you are observing? Around the central atom, how many bond pairs are there?
2.
2. And do you find any lone pair?
No.
No. So if this is the case, when there around the central atom, there are only 2 bond pairs and no lone pair, then the geometry of electron is going to be linear, that electrons are exactly opposite to each other, right?
Yes, sir.
And the shape of the molecule is also going to be linear, and when there is a linear case, the bond angle is 180. Is this understandable?
Yes, sir.
So if you look over here, this is our first case, right? When there is a low lone pair, total electron pairs are 2, bond pairs are 2, then the geometry of electrons would be linear, the shape of the molecule would be linear, the bond angle is 180. There are 2 examples, BeCl2 and CO2, because if you see CO2, there are 4 bonds, but as I have told you earlier, for the purpose to decide the shape, we consider the 2 bond pairs which are adjacent, which are between the same atoms, only a 1. So there are 2 bond pairs over here. And in beryllium chloride, there are again 2 bond pairs, right?
Yes, sir.
Is this example is clear?
Yes, sir.
Okay. Now, have a look at third case. I have put one more bond pair. So if you see, if there now there are 3 bond pairs, obviously it's in a circular, the 3 atoms are on the same plane to the central atom, isn't it?
Yes, sir.
So if I start joining these 3 atoms, so isn't it make a circle?
Yes.
Okay, so what is the angle of a whole circle?
360.
360. And all 3 are bond pairs.
Yes.
So it means all 3 repel each other with the same force.
Yes.
So they are going to be exactly at the same distance from each other, right?
Yes, sir.
So if you divide 360 with the 3, what you will get? 120 degrees. So the bond angle over here would be 120 degree.
Oh, okay.
See, is this understandable? See, it's
Yes,
a
sir.
circular, they arrange themselves and making the whole circle, right? Because they are at a one plane. So if they are at a one plane, so now how you will decide its shape? Planar. And how many angles are there? Only 3, right?
Yes, sir.
So that's why we call this shape triangular planar or trigonal planar. Understandable?
Trigonal. Yes, sir.
So see, the electron geometry is trigonal planar and the molecular geometry is also trigonal planar, because around the central atom, there are 3 sides, there are 3 atoms, right?
Yes, sir.
Is this clear?
Yes, sir.
Okay. So this was our second case. See, when there are 3 pair of electrons around the central atom and all 3 are bond pairs, then the shape of the electron geometry would be trigonal planar, molecular shape will be trigonal planar, and the bond angle would be 120. Here we have an example, AlCl3, HNO3, BF3, and carbon-carbon double bond. So see over here, if you see, we did these examples earlier. See, in HNO3, if you look at this nitrogen,
Yes, sir.
how many electron pairs around this nitrogen?
3.
Sorry,
3.
3. And see, there is a one dative bond. So the lone pair of a nitrogen is moved over here, and 3 unpaired electrons of nitrogen are here, which are bonded by the covalently bonded by the oxygen.
Oxygen.
So there are 3 bond pairs and no lone pair, right?
Yes, sir.
So it means here the angle is going to be 120, whether this one, or whether this one.
But with the oxygen that is connecting with hydrogen and nitrogen, that's going to be 180, right?
Yeah, that is going to be different case. We are now right now considering this as a central atom, and when I consider this as a central atom, I will say the bond angle over here is 120 and the shape over here is trigonal planar. Is this clear?
Yes, sir.
Okay. Now, if you look at this oxygen, oxygen is in group 6. How many electrons oxygen has in its valence shell?
6.
6. So oxygen is sharing one electron over here and one over here, right?
Yes, sir.
So how many bond pairs are there?
2.
2. How many valence electrons of oxygen are left behind?
4.
4.
There are 2 pairs.
So there are 2 lone. So in total, there are 4 electron pairs. From 4 electron pairs, 2 are bond pairs and 2
2
are
are
lone
lone
pairs.
pairs.
So this would be obviously a different case that we will be going to study.
Okay, okay.
So its angle is not going to be 120. 120 is the angle over here, and over here. And the shape around this nitrogen is going to be trigonal planar. Is this clear?
Yes, sir.
Okay. So in the same way, here we did these. Where were these? Yeah. So see over here, it's BF3. Boron has a 3 bond pairs and there is no lone pair, right?
Yes, sir.
So it means the bond angle would be 120 and the shape would be trigonal planar. With aluminum chloride, there are 3 bond pairs
Same
and no
case.
lone pair. So again, the shape would be
Yes,
the
sir.
same trigonal planar and the bond angle is 120 degrees. Understandable?
Yes, sir.
And
Yes,
over
sir.
here, if you see around beryllium, there are 2 bond pairs and no lone pair. So what would be the shape?
It's gonna be linear with angle 180.
Very good. So see, it's easy.
Yes, sir.
If you are able to visualize properly, then it will become easier.
Okay.
Okay. Any confusion till here?
No, sir.
Okay. So we are done with these two cases. Okay. Now have a look over here. If I remove one bond pair and instead I put one lone pair. So now what happens? How many electron pairs now?
Mm,
I,
Eight.
re- I repeat my question. How many electron pairs?
3.
3. Out of these 3, how many bond pairs?
2.
And how many lone pair?
1.
1. So as you recall, we have discussed that the repulsion between bond pairs is lesser than the repulsion between a lone pair and a bond pair, right?
Yes, sir.
So it means this lone pair over here is going to repel these bond pair with the greater force. So as a result, these bond pair gets little away from the lone pair and comes closer to the bond pairs. Come closer to each other. Is this understandable?
Yes, sir. So the angle between the bond pairs is gonna be lower, and the
Lower than
angle
which?
between the lower than the lone pair and the bond pair.
Lone pair and the bond pair. And another thing to recall, if all of these are 3 bond pairs, then what is the bond angle?
Trigonometric planar.
If this lone pair, if I replace this lone pair with a bond pair,
Yes, sir.
then what was the bond angle?
Trigonal planar.
Yeah, shape is trigonal planar. What was the bond angle?
120.
120. Now think, when there are all 3 bond pairs, the bond angle is 120, right?
Yes, sir.
So if instead of one bond pair, if one bond pair is replaced by lone pair, so as a result, the bonds which are at a distance of 120 degrees, aren't they come closer to each other?
Yes, they do.
So the angle is decreased by, is lesser than 120.
Yes, sir.
Did you understand this point?
Yes, sir.
Okay. Now, if you see, there are at 3 places the electrons are there, right?
Yes, sir.
So what will be the electron geometry?
Gonna be a circle.
What was the electron geometry? See, in the previous case, there are three pairs of electrons around the atom. Here, there are three pair of electron around the central atom. In both the cases, this is common. The only difference is that in the previous case, all three are bond pair, and here there are two bond pairs and one lone pair. But the arrangement of electron are almost the same as the previous one, right?
Yes, sir.
So, what was the electron geometry then?
Trigonal planar.
Trigonal planar. But do you think the shape would be trigonal planar in this case?
It is a circle. It's gonna make a circle.
No, but there is no atom on the top. The atom, there is a central atom, and those two atoms are actually declined from the central atom on the left and the right.
Yes, sir.
So electron geometry would be trigonal planar, but the shape would be considered as bent, because when we are considering the shape, we are looking at the atom. So there is no atom on top of the purple atom, right?
Yes, sir.
Because it's just the electron cloud, but there are two atoms, one on the left and one on the right of the purple atom, but they are in the declined form. They are not at the same, exactly, you can say parallel or on the same plane, right?
Yes, sir.
So that's why the shape becomes bent. Did you understand this?
Yes, sir.
If I remove this lone pair, see, they become exactly close in this way. They get arranged in this way, and the shape and becomes linear, and the electron geometry also become linear. But when I put a bond pair, then the electron geometry would be the trigonal planar. But now there is a atom on the top of the purple one. That's why shape would be the trigonal planar. But if I replace this bond pair with the lone pair, then the shape becomes only bent, because there are two atoms on the right and left of the central atom, but at an angle, not exactly on the same line. Is this understandable?
Yes, sir.
So the bond angle would decrease to from 120, and we normally examiner accept 117, 118. So I would just ask students to remember 118 degrees. Any confusion till here?
No, sir.
Okay. If you see a real molecule of this, we have SO2. See. Now, if you see the bond angle, here they are showing 119. But the concept is that now it is not going to be 120, because the electron pair on the top of the central atom is not the, bond pair. So it will repel more, due to which the bond pair gets closer to each other. And due to this, the bond angle decreases from 120. Any question?
No, sir.
Okay. So if I show the bond angle over here, it's just a model to make the students understand. So that's why here they are not, decreasing the angle. So if you have to look at how much the angle is decreased, or angle is whether decreased or not, you will go for the real molecule. Okay.
Yes, sir.
Okay. Now, so we are done with this, our third
Third
case.
one as well. Yes.
Three pair of electrons. Out of these three, two are bond pairs. One is lone pair.
One is lone.
Trigonal planar. The electron geometry is trigonal planar, and the shape we either call it bent, non-linear, angular, V shape.
Bent this one.
Bond angle is 118 degrees. And the example of the molecules are SO2 and ozone, which we have discussed in the last class. The ozone, if you see, let me show you.
Yes, sir.
Dative bonding, we have discussed it, where it is. See, so this oxygen, if you look at this oxygen, has one lone pair and two bond pairs, right?
Yes, sir.
So that's why the angle decreases from 120. Is this clear?
Yes, sir.
Okay. Now, can we think of any other possibility of the bond pairs and lone pairs having the total electron pairs 3?
we could have one bond pair and two lone pairs.
If if this is the atom A and it has a one bond pair and two lone pair,
Mm,
so do the central atom exist?
No,
No.
because
So it
there
means,
has to have two bond pairs.
yeah. So it means we are done with the total electron pairs with 3.
Okay.
Okay. So now the next case is, one minute. It was nine. Okay. Now the next case with the 4 pair of electrons, right?
Yes, sir.
Okay. So see, now I have put a 4 pair of electrons. Now if you see, now it becomes 3D, isn't it?
Yes, sir.
And for example, if I keep the 2 bonds on the horizontal plane, let's have a look. See, now these 2 bonds are horizontal plane. That's why you are not seeing the 4th bond, right?
Yes, sir.
So see, when the 2 bonds and the 2 atoms along with the central atom come on the same plane, one atom that is over here, which I am shaking, goes up the
Behind.
plane and the other one
Yes,
goes down the plane. Is this understandable?
yes, sir.
Okay. So if I see the electron geometry, there are 4 electrons are surrounding the central atom. So the electron geometry is called tetrahedral. Is this clear?
Yes, sir.
So what would be the molecular geometry or the shape of molecule?
Right. Paper.
Yes, it is also
So,
going to be considered as a tetrahedral. Okay, now tell me, all are bond pairs, right?
yes, sir.
So it means they all repel each other with the same force.
Yes, sir.
So there is going to be a same angle between all of them. So let's have a look at that bond angle. And if you remember, that bond angle is 109.5 degrees, isn't it?
Yes, sir.
So whichever angle you see, so it's simple, but you have to remember this. If the central atom has a 4 bond pair of electrons and no lone pair, then in that case, around that central atom, the arrangement of the electrons is considered as tetrahedral. The shape of the molecule around that central atom is considered as tetrahedral, and the bond angle is 109.5 degrees. Is this clear?
Yes, sir.
Okay. So that is our 4th case. See over here. Ammonium ion is the example of this one, methane is the example of this one, and alkanes is the example of this one, and any other atom where you see the atom is forming 4 bond pairs and there is a no, lone pair.
Okay.
Okay. Now, what we can do, we can keep the 4 pair of electrons in total, but make 3 bond pairs and 1 lone pair, right?
Yes, sir.
So if there is a 1 lone pair, what will happen? That, okay, the electron geometry would remain same or changes,
Electron geometry will remain same
but the shape would
because change.
change. So we'll see how the shape will change. So it means the electron geometry would remain tetrahedral, right?
Yes, sir.
Okay. So what happens to the bond angle?
It would decrease because
It
of the
decrease,
repulsion.
and it decrease from which
Because
value?
109.5.
109.5. So remember, whenever there is an electron geometry of tetrahedral, each lone pair contribute to decrease in 2.5 degrees of bond angle.
Lone pair. Okay.
Yeah, when we add one lone pair, the bond angle is decreased by 2.5 degrees, and if I add another lone pair, the bond angle is decreased by further 2.5 degrees. And when the electron geometry is trigonal planar, the bond angle is decreased by 120 degrees. Oh, sorry. The bond angle is decreased by 2 degrees to give you the bond angle when having a one lone pair.
Okay, sir.
Okay. So let me remove the bond angles and let me remove the molecular geometry as you have already predicted. If I replace one bond pair with a lone pair, So see, the electron geometry is again tetrahedral, right?
Yes, sir.
Now, if you look at the shape, can you decide which shape it would be?
Gonna be tetrahedron.
Sorry?
It's gonna be bent tetrahedron
No,
because
bent,
it's
not,
bending.
not bent, because bent is only when this is the case, then it is considered as bent because there are two bonds only. Okay.
Oh, yes,
But
sir.
there are three bonds. You can see, isn't it three-dimensional?
Yes.
Okay. And all the three bonds are going to in the declined position from at the angular position from the central atom, right?
Yes, sir.
So isn't it making a pyramid?
Yes.
And how many faces this pyramid has? There are three angles, right?
Yes.
So it is going to be considered as trigonal pyramidal.
How does it have three faces? Wouldn't it have four?
The fourth one is a base. If you keep it like this, it's more easier not by faces. You can consider it by the angles. There are three angles.
Yes, sir.
And due to those three angles, it is becoming a pyramid. So that's why we call it
Yes.
trigonal pyramidal. Is this clear?
Yes, sir.
If you have any confusion being it a pyramid, please ask.
No, sir.
Okay. Now, as I have told you, when it is a tetrahedral, when the shape would be the tetrahedral, what was the bond angle?
Bond angle was 109.5.
So if it's a lone pair, I told you to decrease the bond angle with the 2.5. So what?
2.5.
So what will be the bond angle now?
107.5.
107, because we are decreasing by 2.5,
7.
right? Okay. Okay. Can you
Yes.
think of any molecule who have this orientation? Having three bond pairs and one lone pair?
3 bond pairs and 1 lone pair.
We have studied yesterday.
Yes.
Ammonia.
Ammonia, yes.
Nitrogen has three bond pairs and one lone pair, right?
Yes, sir.
So see, look over here. Okay, they are saying 107.8, but they show you the concept now it is decreased from 109.5, right?
Yes, sir.
Okay, Cambridge accepted as a 107 only, but in this model, when I show the bond angle, they keeps the same. So that's why I have mentioned the bond angle over here. See.
Okay, sir.
Is this clear?
Yes, sir.
So for Cambridge, you are going to use these values only, okay?
Okay, sir.
Okay. Now, what will be the another possibility having 4 total electron pairs? We can keep 2 bond pairs and 2 lone pair, right?
Yes, sir.
So if I replace one bond pair with another lone pair, so what will be the electron geometry now in this case?
It's gonna be tetrahedral.
Very good. Now, if you look at the shape, can you tell me what shape it would have? Ignore the lone pairs, just look at the atoms. And how they
Linear.
are, sorry?
Linear. Bent linear.
Are the atoms are bent or linear?
They're bent.
They are bent. Very good, because there are only 3 atoms and both atoms are not on the same plane, are not linearly arranged. They are at the angle
Yes.
to each other. So it's bent. So you can call it either bent, either non-angular, either call it angular, either call it non-linear, or either call it V shape. See, it's a V shape now.
Okay.
Okay, so I will decrease the angle further by 2.5. So if I subtract 2.5 from 107, it is going to be 104.5, right?
Yes, sir.
So it's the model, it is showing 109.5, but when you see the water molecule, you will obviously see the bond angle is 104.5. They have mentioned, they show the concept of decrease in angle, right?
Yes, sir.
So that is our fourth example. No, not fourth, it is actually 1, 2, 3, 4. It's the sixth one, right?
6. Yes, sir.
Okay. Can we think of any other possibility having 4 bond pairs and 1 lone pair?
Mm. Mm.
For with a 4 total pair of electrons, can we make another possibility? Okay.
No, sir.
Okay, I have an urgent call to attend. Can can we have a pause for 5 minutes?
Yes, sir.
Okay, thank you so much. Okay. Yes, Alishba, till here, is it fine?
Yes, sir.
Okay. Now, we do not have any other possibility having a central atom with a 4 total electron pairs beside these 3, right?
Yes, sir.
Okay. Now, then we will move to the next case, which would have a 5 bond pairs or 5 pair of electrons. So let's have a look. If I remove these all and put 5 bond pairs. See, now this would be a shape, right?
Yes, sir.
So if you see, if I make it this way, which shape you will see?
Pyramid.
Is it parametric? Call the shape. It's
If I only see 4, it's tetrahedral.
no, just ignore these 2 bonds which are coming towards you and going away from you. Just think of the bonds which you are seeing right now.
Trigonal planar.
Trigonal, trigonal,
Planar.
planar. Very good. So what would be the bond angle over here?
120.
120. Very good. Now think, if I make it as a base over here, isn't it a pyramid is formed from these 3 bonds and the bond which is on the top?
Yes.
And the same happens below as well.
Yes.
So what I can call it trigonal bipyramidal, because there is at the center, there is a trigonal base. And from that trigonal, there is a 1 pyramid forming on the top and 1 forming below.
Okay.
So it is called trigonal bipyramidal. Okay, you have tell me the bond angle of these 3. It is going to be 120, right?
Yes, sir.
Okay, now the bond which is coming towards you, that bond and the bond which are contributing to make the trigonal planar, what would be the bond angle between these?
They are on the opposite, so 180.
No, those are 180, but I'm talking about these 3 which are in the middle now and 1 on the top. What is the bond angle between the top one and the one which are in the middle?
90.
90. Very good. So see the electron geometry, trigonal bipyramidal, understandable?
Yes, sir.
Shape of molecule, trigonal bipyramidal, and you have identified 2 different angles. One is 120 and one is 90, right?
Yes, sir.
So have a look over here. If you see these 3, 120, and if you
Yeah.
observe the top one from the middle one or the bottom one from the middle one, they are forming 90 degrees.
Yes, sir.
Is this clear?
Yes, sir.
Okay. So there would be more cases having a 5 pair of electron, 1 bond pair and 4 bond pair, and then 2 bond pair and 3 bond pair, which were in a past, I think 7, 8 years back, they were asked, but now they don't.
Okay.
But if you want to see, you can easily figure out C. Now, it becomes seesaw. See, isn't it like a seesaw?
Yes.
So we call it seesaw. If I remove one more bond pair and put a one lone pair, so see, it becomes a T. So we call it T shape.
Okay.
And if I remove one bond pair and make one lone pair, so see, it becomes linear. The electron geometry in all three cases remains trigonal bipyramidal because there are 5 sides around the central atom. The electrons are there. Is this clear?
Yes, sir.
Okay. Now, so we are done with this example. And the example is PCl5. There are 5 bond pairs around the central atom. When we did
Yes.
this in the expanded octet, right?
Yes, sir.
Okay. Now, the next case, 6 bond pairs. See? Now, what will be the bond angle?
90.
90. And what will be the bond angle between the from the top and the middle one, and or from the bottom one or the middle one?
Again 90.
Again 90. So it has only one type of bond, one angle between the bonds, which is 90. Is this clear?
Yes, sir.
Okay. Now, if you see the middle one, isn't it making a square?
Yes, it is.
So the square is making a one pyramid from the atom on the top and one pyramid from the atom on the bottom, right?
Yes, sir.
So what we call it square base bipyramid. That is one name.
Okay.
Okay.
Yes, sir.
And the other name, if you consider the one pyramid only, the both pyramids are connected to each other from the base, right?
Yes, sir.
So the pyramid which is on the top has how many faces?
Including the base, right?
No,
Oh,
because
4.
bases in the bases, if the both the bases are joined, so they are not exposed to the to ourselves, so we are not consider it as a face.
Okay. 4.
4. And that pyramid on the bottom has how many faces?
Again 4.
So total faces are 8, right?
Yes, sir.
So that's why we call it octahedral as well.
Oh,
And in normally Cambridge we use octahedral, right?
yes, sir.
So it has a two names, either square base bipyramid or octahedral. And the
Okay.
example of this was SF6.
Yes,
Is this clear?
yes, sir.
Okay. So, okay. I have one question for you. Now think of this expanded octet, this compound. Tell me its electron geometry, shape, and bond angle.
Okay. It has
Yes.
in actual there are like 4 bond angles, but we're gonna count 2 pairs of bond angles, right?
Two bond pairs. Yeah, very good. There are 2 bond pairs
And 1 lone pair.
and 1 lone pair.
So um
So how many electron pairs in total? There are 3 electron pairs, 2 bond pair and 1 lone pair,
that's
right?
yes, that's gonna be trigonal planar,
Trigonal
and
planar is electron geometry or shape?
it is electron geometry.
Very good. Now what would be the shape?
It's gonna be pyramid.
Sorry.
It's it's gonna be bent,
Very good. And the bond,
and the angle it would be less than 120, so 118.
very good. So see, So now you got the concept how to implement those information on the molecule.
Yes, sir.
Okay. Now I have one question. See, so can you work on this and tell me the bond angle, these two bond angles?
Bond angle.
The green one and the yellow one.
The yellow one is gonna be 120. Oh,
The yellow one is going to be
180.
very good.
And the green one is gonna be 120.
Very good. So what would be the shape of the carbon having the green angle, having a 120-degree?
Trigonal pyramid.
You are talking about this carbon?
Yes.
How many bond pairs it has?
It has 3.
Three. Do it has a one? Do it has any lone pair?
No.
So what would be its shape now then?
Mm,
You can take the help from the chart. See, 3 bond pairs and no lone pair.
bond pairs. No lone pair. Trigonal planet.
Trigonal planar. And over here the shape would be
Linear.
linear. See? Is this clear?
Yes, sir.
Okay, so I have some questions over here. Just go through those questions and look at the shapes, how we make these shapes if the examiner asks you. Okay, and if you have any query, we will discuss those queries in the next class regarding the shapes, and then we will move to the new subtopic.
Okay, sir.
Okay,
Yes, sir.
okay. So do go through these past paper questions, and then if you have any query or any question, please ask. Okay.
Okay, sir.
Okay, then take care. Goodbye. Allah Hafiz.
Love.